So in question 7, this is about internal resistance of a cell. We are told that figure 3 shows a cell connected in series with an ammeter, a 2 ohm resistor, and a switch. A voltmeter is connected across the cell. When the switch is open, the voltmeter reads 1.5 volts. Now, notice that they are describing how we measure the EMF of a cell. First of all, we connect the voltmeter across the cell. Then we open the circuit. So when the switch is open, the reading of the voltmeter, by the way, it will not prevent the voltmeter from reading the potential across the cell. Okay? Because you can see that the circuit for the voltmeter is complete, although the cell is not sending any current to the external resistor. So here they are describing how you measure the EMF of the cell. So this reading of 1.5 volts is actually the EMF of the cell. Given that the internal resistance of the cell is 0.5 ohms, determine the current reading, determine the ammeter reading when the switch is closed. Let's see what happens here. So the EMF of the cell, this E, is 1.5 volts. The internal resistance, we can just write it here, is 0.5 ohms. This is the external resistor, uppercase R, lowercase r. So we are going to close the switch, and now current will flow in this circuit. This is I. Now this current is worked out like this. I is usually given by the EMF over the total resistance in the circuit, which is internal resistance, plus the external resistance. This will of course give me 1.5 volts divided by 0.5 plus 2.0. And this, if you calculate that, it's going to give you 0.6 amperes. It's just as simple as that. So the trick here is to recall how you calculate current when you are dealing with a cell with a given internal resistance. The other trick they have used here is to describe how the EMF of the cell is measured. Remember, when the switch is open, the voltmeter reads the EMF of the cell. When the switch is closed, the EMF reads what we refer to as terminal potential. Terminal potential is always less than the EMF of the cell. However, they've not gone to terminal potential. They've just used two things. Do you realize when they are measuring the EMF of the cell? Do you know how the EMF of the cell is defined? They have described it here. When the switch is open, the voltmeter reads 1.5 volts. So the EMF of a cell is the reading of the voltmeter which is connected across the cell when the circuit is open. And the terminal potential is the reading of the voltmeter when the switch is closed. That is all to this particular question. Let's go to question 8. Question 8 is rather direct. You're asked to state two uses of gamma rays in medicine, and this one is very simple. Gamma rays are used to control and or to manage cancerous growth, or what we call malignant growth. The other use of gamma rays in medicine is in sterilization of medical equipment, that is to kill germs on maybe surgical equipment. So the two uses are as simple as that. Gamma rays are used in the treatment of cancerous body growth and in sterilization of medical equipment. Let's go to question 9.